Let's make a BGP configuration using loopback adapters as our update source and adding in some authentication to better the security of our protocol. In this network, I've got all of the IP addresses configured here that you see. We have ASN 42 in the blue, ASN 88 in the yellow. The laptops are connected to 172 networks, so this would be 172.16.42.0. On the right hand side here, this would be 172.16.88.0. So that third octet is just matching the ASN number to keep things easy to remember. So what I've also done ahead of time, as you can see here, is I've configured the loopback adapters. So loopback 0 on ASN 42 is just 42, 42, 42, 42. That's a slant 32. And on the ASN 88 side, you can see the same thing there. Loopback 0 is just 88.88.88.88, and that is also a slant 32. So what I want to do here is walk through a couple of things on how we actually get BGP to update and be redundant using both of these serial links, but rely on the loopback as the update source. What that allows us to do is to kill off any of these serial links and still have BGP remain up and stable and functional. We're going to start out on the Madison side of things and just jump right into some of this configuration. One of the very first things that I need to do is I need to create a static route for my neighbor's loopback adapter using the exit interface. So what I'm going to do is go into config T. I'm going to create an IP route, and we're trying to create a route to my neighbor's loopback adapter, which from Madison to Fargo, Fargo's loopback adapter is 88.88.88.88. It is a slant 32, so we can just give it that. And then which interface does it need to leave to get there? Simple enough, we'll go serial 000. So, creating a default route to that neighbor. I'm going to do the same thing using the second serial link, which would be serial 001. If we look at our routing table here, if we do a show IP route, we can see we've got the static route and it's accessible over both those serial links. We need to configure the same thing over here on the Fargo side of things. So walking through that same process, going into config T, create an IP route for our neighbor's loopback, which in this case is 42, 42, 42, 42. Give it the slant 32 and serial 000 and serial 001 going across both ways. I'm going to jump back to Madison and we'll walk through the BGP configuration, and we'll jump back over to Fargo and do the same thing in just a second. So in Madison, we start this up the same way we would for normal BGP. So config T, we're going to go through the router, BGP, and what autonomous system number are we? We are number 42. I'm going to tell BGP to talk to the neighbor of 88, 88, 88, 88. So talking to my neighbor's loopback. And the remote autonomous system for them is 88. A couple of things I need to do here. I need to set my neighbor the update source. And we'll see, packet tracer doesn't look like it's going to allow us to do this here, but what we would normally do is do an update dash source and then loopback 0. Okay, so this isn't going to go through, looks like in packet tracer, but I'll at least walk through the steps of commands there. Okay, so assuming that would work, the next thing we would do is change this to a, we would need to do the eBGP multi-hop, set that to 2, and that is to compensate for the BGP having to pass the loopback and the serial, so impacting that TTL. And the very last thing would be to set up the password on it, which would just be password, and then we could do something like Mike, having those match on both sides. So it was a bit unexpected that packet tracer wasn't going to give us the full BGP configuration, But you should at least be able to see here what the process of was. Basically needed to create static routes to our neighbor's loopbacks. We would tell our BGP about the neighbor's loopback is a neighbor, set our update source to our own loopback 0, change the multi-hop, and also put a password on that as well.